Okay, today we will be replacing a 10 kW electric duct heater. Okay, safety first. We need to first verify that the power is off to this electric duct heater. So I'll take my multimeter and my non-contact voltage tester. So you can see we do have 480 volts coming in, so we'll need to shut that off. Sometimes these fan coil units will also have a separate 120 volt circuit coming in, so make sure everything is off. Now that everything is off, we'll go ahead and disconnect and remove our 480 volt wires and conduit from the enclosure. We'll then go ahead and disconnect and remove our low voltage wires and pull them up through into that top control box where the ribs and controller is. Then disconnect and set that top control box aside. You can then go about unscrewing all of the tech screws that hold this electric duct heater to the metal duct. Sometimes these electric duct heaters I've found, they will screw them to a piece of angle iron inside the duct and then rivet the angle iron to the duct. So sometimes you got to take the control panel, the box, the enclosure off as one piece and then pull out the actual heating elements as a separate piece. Sometimes they don't come out together all at once. So you can see where they burnt and where the heating elements actually broke. This unit was almost 40 years old. There it is. So take a close-up look. You can see the burn marks on the ceramic insulators there, those little insulator bushings. An even closer look, you can actually see where they broke apart, got hot and melted and broke apart. Here's a new one. Again, 10 kW, 480 volt. Has thicker heating elements. This is, again, three-phase, 480 volt, single step. It's important to note the airflow because they're not all the same. So make sure when you replace one, you replace it like for like to get proper airflow in the proper direction and the proper kW rating and voltage rating. There's a better look. You can see those wires or the electric heating elements are thicker than the old one, so that's nice. This is from Warren Technologies. Let's see, this unit was $200 on Vumi.com. Again, control volts is 24. Here's our wiring schematic. Now I'm going to do a slight modification to this. We're not going to be using the fan relay that you see there. I'll also be installing an air pressure proving switch. So when the blower fan is running, it'll close that air pressure switch, which will say, okay, it's safe to turn on the electric heating elements. If you're getting value out of this video, please consider subscribing. It helps the channel move up in the YouTube algorithm. So let's install the new one. It gets installed with tech screws. You can see I already got the air pressure switch installed in there, as well as my step-down transformer in the bottom left corner. That step-down transformer steps at 480 volts down to 24 volts. So keep that in mind if you replace one of these electric duct heaters. They don't come with that step-down transformer if you're buying one of the stock line Warren Technology ones. They also offer custom ones where they can install it for you, but it's pretty quick and easy to reinstall your own step-down transformer and air pressure switch. Just getting it secured to the metal duct with several tech screws. you notice a small gap at the top right corner? That is because the old 10 kW electric duct heater was slightly taller than this new one. The new one's more compact. So we're going to use properly rated duct tape for this application. Seal everything up really nice, all the seams, all the way around, because we don't want any air leakage. And then you can also come back and put mastic. But yeah, Warren Technologies, I've had good luck with their electric duct heaters. They come pretty much ready to install. I just install our step-down transformer and air pressure switch. Okay, we'll reinstall our top control box. And the top control box has our controller and the ribs, which stand for relay in a box, along the side of the control box there. So you got two ribs for your low, one for low fan speed, one for high fan speed, two more ribs, one for single stage heat and then the second stage heat. However, in this case, this is a little 10 kW electric duct heater, so it only has one stage. Whereas if this was like a 20 kW duct heater, it would be two stage. Again, the power's already still off. I'm just double checking. We'll go ahead and carefully feed in our 480 volt wires into the box. And generate 480 volt wires sort of universally. Again, not in every situation, but most of the time. If you remember boy, brown, orange, yellow. So if you're trying to figure out which wires go where, usually I always try to just do brown, orange, yellow. So brown on lug 1, orange on lug 2, yellow on lug 3, and then of course remember to land your green ground wire on the grounding lug. Okay, we got our 480 volt wires hooked up. Now we'll move on to our lower voltage wires, 24 volt control wires. I apologize for the BX cable getting in the way of the shot. You can see I'm landing my wires on my air pressure switch and to the coils on the relays. Then I'm following my wires up to the ribs to make sure I'm hooking up the correct wires to the correct ribs. So if you're not quite sure or understanding how this works, basically the BAS system talks to this controller in this top box, and then that controller will send a 24 volt signal to the rib to turn on the electric heating elements. And again, if the blower fan is running, that air pressure switch will be closed. It'll allow the signal to complete to the coils on the electric heating element relays. And the switches will close inside the relays, send 480 volts to the electric heating elements to start heating. So I hope that makes sense. And if you weren't clear on the coils on those relays, there's two terminals. One's for your 24 volt AC hot, and then the other side would be your 24 volt AC neutral wire, if you will. And that's what the orange wires are. And so on the air pressure switch, that's all the 24 volt AC neutral side of the circuit, of the control circuit, if that makes sense. So we'll finish up the wiring, turn the power back on, start it up, check our temps coming out of the ceiling registers, and we should be good to go. You may smell a burning smell when you first start one of these brand new. That's normal. Please like, share, subscribe, leave me a comment, and thanks for watching.